welcome back guys. We're gonna solve a follow-up question to a previous one that we covered in the channel. If you guys didn't get a chance to watch that video, I'm gonna put the link in the description. It'd be probably easier to follow this one. What we have in here, we know that T-shaped brackets that we had in the previous question, we needed to determine the reactions at point A and B in two different conditions. And in this one, we need to determine the smallest distance A if the bracket is not to move. So I'm gonna draw the free body diagram again. So what we have in here, we have this T-shaped bracket that has two different supports at point A and B. So in the previous question, we showed that the reaction at A will be in this direction, and there is no bx since that's the only x force. So our bx will be 0, and we will have the force by in here, and the rest of this is the forces that we have in the figure. So 40 here, 50 pounds here, we have a 30 in here and 10 in here, and what we're interested in here is the distance A. So what we did was we did our equilibrium equations, and we did the sum of all forces equals 0, and same for the moment, and we started writing the moment about point B. And let's recap one more time the moment that we have about point B. So we have the moment of the 10 pounds force, 30 pounds, 40, and A. Let's just write it again. We're going to use the 2D shortcut that we have for finding the moment. I'm gonna put the link in the description below. So we have the 30 pounds force, and since the moment of 30 pounds force about point B is clockwise, it will be negative. So we have minus 30 times A, which is the distance. So for that 2D shortcut, you're interested in the vertical force, or our force in, I should say, our force in X and Y direction, and the vertical distance to the line of action. So this will be the line of action, and this is the distance that we have, which is A. So we have the same for all of the other forces too. So we have the moment of 10 pounds, again clockwise negative. This time will be A plus 8. On the left side we have the 40 pounds force, which this time the moment will be counterclockwise. So we have a positive moment, 40, and the distance is again this distance, which we know is 6 inches. And last one is the moment of the force A, since it's downward, again same direction, counterclockwise moment, A times distance will be this distance, which is 6 plus 6 or 12 equals 0. Based on this, we found our A, which was 40A minus 160 divided by 12. And that's what we found. Let's get back to the condition that we have in the question. So we have to determine the smallest distance A in order to avoid moving of the bracket. So what's happening in here is that the higher the distance A gets, we will make a higher moment about point B, because that would be the moment of 30 pounds force, and the higher we have for A, we have a higher moment from the 30 pounds force, and same for the 10 pounds force. Because our distance is a positive amount, the more A that we have, the higher moment we're gonna make, and that's why the question is asking for the smallest. So if we have our A small enough, we can get the force or the reaction at point A 0. So that way we know that we have a roller at point A, and it can either put force downward, and the least amount for that is to have that force 0, which means we will have, so we know our A has to be equal or greater than 0. And if that's the case, in order to have our A minimum, so our A will be, so we want to write A based on the reaction at force A. So we'll have 40A minus 60 equal minus 160 equals to 12A. So our A will be 12A plus 160 divided by 40. So as we can see, in order to have the A minimum, these are all positive numbers. So in order to have this minimum, we have to have this part equal to 0. And it can be negative because it's a roller, it's not a pin. So for that, our minimum A should be where we have the A0. So once we have our A0, our distance will be minimum, and this will be 160 divided by 4, which is 4 inches. That would be all for this question. Thanks for watching, and I'll see you guys in the next video.